I'm going to show you how to master the art of requirements writing. Hi, I'm Daryl Frank. I'm a principal systems engineer with over 25 years experience in military aircraft weapon systems integration and certification. I even wrote a book called Requirements to Reality to explain this exact mystery. Every great system, whether it's a fighter jet, a smartphone, or the car you drove in this morning, starts with one thing: well-written requirements. But here's the problem. Most engineers think writing requirements is just typing out what they want the system to do. Simple, right? Wrong. Poorly written requirements are one of the biggest causes of project delays, cost overruns, and even mission failures. Today, I'm going to show you the right way to write requirements. By the end of this video, you'll know how to write requirements that are clear, testable, and bulletproof. Think of requirements as the DNA of your system. Every design, test, and piece of documentation grows out of them. Let's break down what makes a requirement good. There are 9 key characteristics. Think of these as your quality control filters. Necessary? Does the system really need this? If not, cut it out. Appropriate? Is the level of detail right? A top-level requirement shouldn't dictate bolt sizes. Save that for lower levels. Unambiguous? Will everyone who reads it understand it the same? If not, rephrase. Complete? Does it fully describe what's needed without gaps? Singular? Does it express one idea, not 3 mashed into one? Feasible? Can we actually build and verify it with the available resources? Verifiable? Can we prove it through inspection, test, or analysis? Verifiable? Is it correct? Does it accurately reflect the stakeholder's true need? Is it correct? Does it conforming? Does it follow the agreed style and format? So here's an example of a bad requirement. The system shall be easy to use. A good requirement? The system shall allow a first-time user to complete the login process within 30 seconds without prior training. See the difference? The second one is measurable, testable, and leaves no room for debate. It's not just about individual requirements. As systems engineers, we care about the set as a whole. A set of requirements should be complete. It covers everything needed to define the system. Consistent. No contradictions. If one requirement says the aircraft must carry 2 passengers and another says 4, you've got a problem. Feasible. The whole set can be delivered within the cost, schedule, and technical limits. Comprehensible. Stakeholders and engineers can understand it without needing a translator. Validatable. You can demonstrate that the set leads to meeting actual goals. Think of a set like a jigsaw puzzle. Each piece, each requirement must fit into the others and build a coherent pictures. If one piece is missing or shaped wrong, the whole system suffers. A requirement isn't just a sentence. Behind it are attributes, the metadata that makes it useful, traceable and testable. Some of the most important attributes include rationale. Why does this requirement exist? Traceability. What higher-level need or stakeholder does it come from? Verification method. Will we test, inspect, analyze, or demonstrate it? Priority and risk. Is this critical to mission success, or is it just a nice to have? A unique ID, so we can track and reference it across documents and tools. Without attributes, requirements are just words on a page. With attributes, they become part of a living system model that can be managed, tested, and maintained. Here's the part most engineers skip: the actual rules of writing. INCOSE lists 41 of them, but don't worry, I won't bore you with every one. But at least let's go through the essentials. Use full sentences, subject, verb, and object. Don't write fast response time. Write, the system shall provide a response within 20 milliseconds of user input. Use an active voice. Don't write, data shall be processed. Write, the system shall process data. Avoid vague words like some, many, or as appropriate. Avoid escape clauses, like where possible or if necessary. These let people wiggle out of responsibility. Be measurable. Always state units, tolerances, and conditions. Avoid absolutes. Words like always, never, or 100% reliable are usually unrealistic. Also, one requirement, one idea. No bundling conditions into one sentence. Also use consistent terminology. If you say operator in one requirement, don't switch to user in another. Following these rules might feel strict, but they would stop projects from falling apart later. Requirements writing isn't just admin work, it's engineering craftsmanship. Every requirement you write is a commitment, a promise between stakeholders, designers, and testers. So before you finalize any requirement, ask yourself, can this be tested? Is it truly needed? Is it written so clearly that no one can misinterpret it? If the answer is no, rewrite it. Here's a tip from an experienced engineer. Write requirements as if you're leaving instructions for someone who will never get to ask you questions. That forces clarity. So here's the takeaway. Requirements are the seeds of your system. Plant them poorly and you'll harvest confusion, cost overruns and failure. Plant them well and you'll build systems that actually work, on time, on budget, and to spec. That's the art of requirements writing. If this helped you, hit like and subscribe and share it with your fellow engineers. And remember, engineering starts with clarity. If you like this breakdown, hit subscribe. I've got more episodes coming up. And don't worry, I keep the explosions metaphorical. Check the description for the link to my book, Requirements to Reality, which explains systems engineering in simple language.